Hello everyone, today's lesson will be rate of reaction. The rate of reaction is defined as the change in the amount of reactants or products per unit time. We usually use water displacement method to collect the gas. Here we have two examples of collecting hydrogen gas from it. The reaction is the fastest at the start when the reactants are at maximum, steepest gradient. The gradient becomes progressively less as the reactants are used up and the reaction slows down. Finally, the graph levels out when one of the reactants is used up and the reaction stops. The amount of product depends on the amount of reactants used. The initial state of reaction is obtained by measuring the gradient at the start of the reaction. A tangent line is drawn to measure the rate of reaction at instantaneous time. Different chemical reactions occur at different rates. We have two types, fast reaction and slow reaction. For fast reaction, the time taken for a fast reaction is short. The rate of reaction is said to be high. For example, finding of dyes on a shirt under hot sun, burning of petrol in car engine, striking a match, ripening of tomatoes. At the slow reaction, the time taken for a slow reaction is long. The rate of reaction for a slow reaction is low. For example, a piece of newspaper turning yellow, watering of limestone by acid rain, rusting of water pipe. Here we have some examples of fast reactions. We have the types of reactions. As we have mentioned, there are combustion, reactions between metals and water, reaction between metal carbonate and an acid, precipitation, double decomposition. On slow reaction we have photosynthesis, rusting and fermentation. Observable changes for measuring the rate of reaction. We have precipitation formation, change in mass during the reaction, color change, temperature changes, pressure changes, volume of a gas liberated. Finding the average rate of a reaction. The rate of reaction is a measure of how fast a reaction occurs or how much a reactant or product change in a period of time. The rate of reaction is equal with the quantity change of reactants or products over total time of the reaction. The calculation of the reaction is measurable quantities and immeasurable quantities. During a chemical reaction, two things happen. The quantities of reactants reduce, the quantities of products increase. Therefore, the rate of the reaction can be determined by the measuring the decrease of the amount of reactants over time, measuring the increase of the amount of the products over time. However, the quantity or change of the reactants or products may be measurable or immeasurable. The easily measured quantity changes include mass, concentration, conductivity, and volume of gas. For example, the reaction between calcium carbonate and hydrochloric acid. The rate of the reaction can be determined by measuring the reduces of mass of the calcium carbonate, the reactants over time, measuring the increases of volume of the carbon dioxide gas produced over time. In some reactions, some changes are observable but difficult to be measured. For example, change in color and precipitation. The time taken for the color of the reactant to change or certain amount of precipitate to form can be used to measure the rate of the reaction. If the quantity change is immeasurable. The rates of reaction is equal with 1 over total time for the reaction. Analyzing the reaction from the graph. Graph of product or reactant change against time. In a chemical reaction, the reactants will decrease over time and the product will increase over time. The rate of the reaction will decrease over time because the decrease in the concentration and total surface area of the reactants. In a graph of quantity of product or reactant over time, the rate of reaction is equal to the gradient of the graph. Here we have an example. We have volume in centimeter cube and time in seconds. In a reaction between calcium carbonate and liquid hydrochloric acid, carbon dioxide gas that is released is collected in a burette. The graph shows the volume of carbon dioxide collected over time. Find the average rate of the reaction in the first 60 seconds. Finding the instantaneous rate of a reaction from A graph, the rate of reaction changes from time to time as the reaction happens. The rate of the reaction at the particular time is called the instantaneous rate. The instantaneous rate of reaction is equal to the gradient of tangent at the particular time. Then we do the equation. Rate of reaction is the difference of the product over time. Difference of product, change of the amount of product, difference in time, change over time. The graph shows a volume of carbon dioxide gas released over time in the chemical reaction. Find the rate of reaction at time equal 40 seconds. Factors that affects the rate of reaction. As we mentioned in the previous lessons, we have size of the solid reactants, concentration, catalysts, and temperature and pressure. The smaller the size of the particle, the bigger the total surface area. The bigger the total surface area, the higher the rate of the reaction. We have here an experiment. The reaction between hydrochloric acid and calcium carbonate. Experiment 1. 25 centimeter cube of 0.5 mole over decimeter cube hydrochloric acid with calcium carbonate chips. The carbon dioxide gas released is collected in a burette. The volume of gas released is recorded in every 30 seconds. The result is plotted in a graph. The second experiment is 25 centimeter cube of 0.5 mole over decimeter hydrochloric acid with calcium carbonate powder. As in the experiment 1, the carbon dioxide gas released is collected in a burette and the volume of the gas released is recorded in 30 seconds. The result is plotted in the graph as in experiment 1. So, we have a combustion. Here is the graph of volume of carbon dioxide in centimeter cube and time. Experiment 1 and experiment 2. The gradient of the curve of the experiment 2 is greater than the curve of the experiment 1. This indicates that the rate of reaction in experiment 2 is much higher than experiment 1. Conclusion: the smaller the particle size of the reactant, the bigger the total surface area. And the bigger the total surface area, the higher the rate of the reaction will be. Concentration of the reactants. The higher is the concentration of the solution, the higher is the rate of reaction. One experiment. By measuring the time taken for the formation of sulfur precipitate, yellow solid, when sulfuric acid reacts with sodium thiosulfate 6. Different concentration. We can investigate the effect of concentration of the reactant on the rate of reaction. The procedure will be 50 centimeter cube of 0.2 mole per decimeter cube sodium thiosulfate and 10 centimeter cube of 0.5 moles per decimeter cube sulfuric acid. From view is recorded. The experiment is repeated by using sodium thiosulfate solution with concentration 0.4 mole per decimeter cube, 0.6 mole per decimeter cube, 0.8 mole per decimeter cube, and 1 mole per decimeter cube. The conclusion: the graph of the concentration of sodium thiosulfate against the time taken of the sulfur precipitate is plotted. As the concentration of sodium thiosulfate solution decreases, the graph will go upside down, starting from epsilon going to x over time. Temperature of the reactant. The higher the temperature of the solution, the higher the rate of reaction. By measuring the time taken of the formation of sodium sulfur precipitate, when the sulfuric acid reacts with sodium thiosulfate again, different temperature can be investigated the effect of temperature of the reactant on the rate of reaction. Same thing for the experiment, but now we have to use temperatures. The experiment is repeated by using sodium thiosulfate solution with temperature on 35, 40, 45 and 50 degrees. The conclusion: the graph of the temperature of thiosulfate against time taken of the sulfur precipitate to form is plotted. As the temperature of sodium thiosulfate decreases, the rate of reaction decreases. Pressure of the gas. For the reactions involve gas, the rate of reaction is affected by Pressure of the gas. Pressure does not affect the rate of reaction where the reactants are in form of solids or liquids. The higher the pressure, the higher the rate of the reaction. Catalyst. Catalyst is a chemical substance that changes the rate of the chemical reaction. The characteristics of the catalyst. It is specific in its action. It can only catalyze a particular reaction. Changes the rate of reaction. During the reaction, the catalyst remains chemically unchanged but may undergo physical changes. For example, catalyst may turn into powder during the reaction. Does not change the quantity of products formed. Only a small amount of catalyst is needed to increase the rate of reaction. An increase in the quantity of catalyst will increase the rate of reaction slightly. Catalysts provide a different reaction path with low activation energy. As we mentioned in the previous lessons, the activation energy is the energy that is used for a reaction to happen. List of the reactions in the catalyst. We have here some examples. Factors that do affect the catalyst. A catalyst is a substance which can change the rate of reaction. As we mentioned, there are two types, positive ones and negative ones. The positive ones increase the rate of reaction and the negative ones reduce the rate of reaction. Otherwise, we call them inhibitors. Collision theory. The collision theory states that the particles of the reactant needed to touch to enable bond formation or breaking to happen. Collisions of particles of reactant substance need to achieve a certain minimum of energy, activation energy, in order to produce a reaction. Particles that collide also need to have the correct orientation of collision. According to the collision theory, atoms, ions, and molecules can react to form products when they collide with one another, provided that is colliding particles enough of kinetic energy. The activation energy, as I mentioned, is the minimum energy that the reactants particles must achieve at the time of a collision in order for a chemical reaction to take place. The value of the activation energy is different in reactions. The reaction with the high activation energy occurs slowly, whereas the reaction with the low activation energy occurs fast. The energy profile diagram. In this diagram, the activation energy is shown by the difference in energy between a peak of the graph and the level of energy of increasing the substance. We have exothermic and endothermic reaction. Factors that affect the rate of reaction. Explanation of the collision theory. The total surface area of the reactants. When the size of the solid of a substance that reacts is smaller, the total surface area exposed becomes larger. This causes the collision frequency between the reactants increases. As the result of the frequency of effective collisions also increases, hence increases the rate of the reaction. Presence of the catalyst. When a positive catalyst is used in a reaction, the catalyst prepares an alternative path of the lower activation energy for the reaction. As a result, the frequency of the effective collisions increases and hence increases the rate of reaction. The concentration. Solution with higher concentration has more particles per unit volume of the solution. As a result, the collisions frequency between the reactants increases. Consequently, the frequency of the effective collisions also increases and hence the rate of the reaction increases. The temperature. When the temperature of the reaction increases, the particles of the reacting substances move faster. This causes the collisions frequency between the reactants to increase. As a result, the frequency of the effective collisions also increases and hence increases the rate of reaction. The pressure. For a reaction that involves the gas, when pressure increases, the particles of a gas are compressed to fill the spaces that are small. This makes the number of particles of a gas per unit of volume to increase. This causes the collisions frequency between the reactants increased. As a result, the frequency of effective collisions and also increases and hence increases the rate of reaction. Some scientific knowledge to enhance the quality of life. You can check it by yourself. For homework, the PowerPoint presentation. The title is Rate of the Reactions and the Factors that affecting it. The deadline is for Monday. Thank you.